All right, we have to convert the z-score for the 24,869 and the z-score for 82,249. And once you convert this z-score, what do we need to do? Well, we have to go to our chart and extract out the two area corresponding to the z-score. So the two area I have here, which is again 0.0139 and 0.9452. What do I do with the two area? Well, hopefully you guys answer it. We take the two area and subtract among themselves, which is I have 0.9313, which is what do we interpret? How do we interpret this thing? We just say that the probability that the teacher earned between 24,000 and 82,000 is 90.9313, right? Which is, again, that's a lot of people, right? Meaning, for instance, and again, the next example, you will see the follow-up question. But again, this is basically tell you that, for instance, if there's 100 teacher, right? If we have 100 teacher, 93 of them or 94 of them make between those two values. You know, we don't know how much, but maybe some got 40,000, some have 70,000. But again, 93 out of 100 make between the two income in terms of salary based on this information. Okay, so again, hopefully you guys see that it's very redundant, right? This problem, again, the question is a little bit different because they ask you for probability, but the step and the procedure is pretty much identical. Okay, so let's try one more, and then as you can see, this one here, I just give you a different information, which is this information is related to, you know, drive-through bank, right? If you go to your bank and you have a drive-through. So again, let's say that they give you this, which is the average waiting, which is reminder, the average waiting is the mean, right? The average waiting time for drive-in window at the local bank is 9.1 minutes with the standard deviation of 2.6. So again, they give you the mean and they give you the standard deviation. And ladies and gentlemen, they will always give you the mean and they will always give you the standard deviation for this problem. Assume that the random variable is normally distributed, basically tell you that it's a bell-shaped curve. Find the probability that the customer have to wait the given time when he or she arrive at the bank, right? So again, this is A. They ask you find the probability that they have to wait between 4.94 minutes and 14.4 minutes, 0.4 minutes, right? And again, B is less than 9.36 and C is more than 1638. So again, between, we know between, which is again, you know, between, not, there's no sugar code, right? Between, it's just between the two value. And to find this item between the two value, the first thing we need to do is, again, sketch it to have an idea. And again, we know that between the two value, we have to take the two item and subtract among themselves, but not the z-score, but we have to find our area, right? So we convert to the z-score, which is, again, the z-score for the 4.94 is negative 1.6, and the z-score for the 14.4 is 1.9. And again, we need to extract the, again, I just put the big number first, which is to extract the 1.9 z-score. The area is 0.9713, and extract the negative 1.6, which is the area is 0.0548. What do I do with these two area? I need to subtract them. And again, how do we interpret this thing here? We just say that the probability that the customer have to wait between these two time are 0.9165. And again, just because they ask you for probability, you give them a decimal. If they ask you for percentage, you say 91.65%. Okay? So again, hopefully you guys see that is very consistently the same, right? It is take practice and just like everything else, right? Same thing for B. What does it mean less than? Again, less than meaning the item to the left. And if you recognize that the item to the left, life is good. Why life is good? Because the answer will be the answer in your table. We don't have to do any subtraction. We just find your z-score and find the area correspond to that z-score. But still, we have to find the z-score of the 9.36, which is again 9.36 minus 9.1 divided by 2.6. We'll give you 0.1, right? And again, we go in and we find 0.1. And again, 0.1 is the correspondent is 0.5398, which is, hopefully you guys say that that is the answer. And you are right, that is your answer, which is the probability that the customer weight less than 9.36 is 0.5398. Okay. And again, let's do the last item we have here, which is more than, as the same as before, more than meaning the item to the right, and the item to the right, we have to find a z-score, and then we have to find the area correspond to the z-score, and then we have to take that area and minus from 1, or 1 minus that. So again, the corresponding z-score I have is, again, 2.8, right? I take 16.38 minus 9.1 divided by 2.6, which is now, what do I have? I need to go extract this item and reminder that this is not your answer. Because we're looking for the item to the right, we need to take 1 minus the area, which is 0.0026. Meaning, again, this is what we have is the probability of someone have to wait more than 16 minutes and 38 seconds is 0.0026, right? So again, very, very, if you see this, it's not even 1%, right? It's 0.26 of a percent. So roughly a 1/4%, right? So again, you know, if you go to 203, we would say that this is very unusual data, meaning not many people going to have to wait more than 16 minutes and 38 seconds. Okay, so again, it's very, very small. Okay, so again, first of all, question here in terms of how to find the area in between, how to find the area less than, how to find the area more than. All right. So if you don't have question, here is a follow-up question. Ladies and gentlemen, this is the follow-up question, which is Alex will ask you guys is, so information is the same, right? Instead of asking you find the percentage, this is the follow-up question. In some of the question they ask you is, you know, based on the information, if 2,000 customers visit this drive-through or drive-in window, how many customer would have the following waiting time? Meaning, how many customers would we expect it to wait between the 4.94 minutes and the 14.4 minutes, right? So now, instead of asking for probability, they ask you what is the amount of data, the amount of people in this case, right? So how do we find this? Which is, again, recall that this is what we find last time, right? Part A, we say that the probability of the people wait between these two times is 0.9165. So what do we do? Well, all you need to do is you take that probability, you take that percentage, right, in decimal form, and multiply to the total item we have, or the total customer in this case. So all we need to do is take the 0.9165 times the 2,000. And everybody see that if I take 0.9165 times the 2,000, I will get 1833. So what does that mean? Approximately 1,833 customers have to wait between those time frames, right? Out of 2,000, 1,833 of them have to wait between those time frames. Okay, so basically all you do is you take the probability that you found, multiply to the total item you have, which is in this